Well, thank you so much for inviting me to this webinar. It is a pleasure. I'm really excited to share my research with you. Like John said, my name's Yiyun. You can call me Yiyun. Yeah, my name, I know it's hard to pronounce, so I accept a wide varieties of my name. That's okay. So I'm a postdoc at the Ohio State University. I work for Dr. Chieri Kubota in control environment, agriculture improvement, plant physiology. Um, and well, so today's presentation I'm going to give is going to focus on characterizing strawberry cultivars so that we can use them to help indoor growers in deciding what kind of strawberries to grow. So strawberries is one of the most popular fresh fruit around the world. The world production value of strawberry is around 20 to 23 billion US dollars, and strawberry is grown in 82 countries in the world. And here's are the top 10 countries that grow strawberries. Number 1 is China, followed by United States, Turkey, Egypt, and Mexico. And in the US, in 1 year, there's 1.3 million tons of strawberries being produced. So what's interesting about the US strawberry production is that even though with so much strawberry production, 98% of the US strawberries actually only come from 2 states, California and Florida. And you can see in this chart on the right that in 2000 and 2019, it can show you the production of strawberries in California, which is represented by the green bar, and the production from Florida, which is represented by the red bar. And the trend of strawberry productions in California usually is the highest going from April to November. And that's where most of the strawberries are produced in the US. And going from December to February, the strawberry production is relatively low. And so that's what's considered as the off-season of strawberries. And most of Florida growers focus on production of strawberry during the off-season, as you can see here. So this slide is going to show you how popular strawberries are in the US. In addition to being the second largest strawberry producer in the world, US is also one of the largest strawberry importers. Most of the strawberries imported into the US actually come from Mexico. Actually, 99% of those strawberries come from Mexico. As you can see in this graph, the blue bar represents how much strawberries is being imported into the US. And the red bar represents how much strawberries imported from Mexico. And from 2003 to 2013, those two numbers were almost about the same every year. And the import of strawberry typically occurs during the off seasons, which makes Mexico strawberries a strong competitor with Florida. Well, importing strawberry from Mexico can actually negatively affect the strawberry market in the US. And this graph will explain why. So the x-axis shows the year from 2003 to 2012. On the y-axis on the left here shows the amount of strawberries either being imported or produced. And the y-axis on the right shows the price of strawberries in the market. So, did I hear a question? Okay. No? Okay. So you can see in this graph that the red bar represents the imports, the green bar represents the production in Florida, and the blue line is the price of the strawberries. And from 2003 to 2012, there's a 3 times increase in strawberry import from Mexico, while the production from Florida stays about the same. And that makes that means that there's more strawberries in the market and making the market more competitive. And because of that, the price of strawberry reduced. Well, this may be a great news for the consumers, but it actually makes it very challenging for US strawberry growers to stay sustainable in terms of production of strawberries. And so it is very hard. And because the cost of production, it is hard for US growers to compete in terms of price in the market. And so one way for them to be able to stay competitive is by growing premium quality strawberries. Premium quality strawberry may include strawberry that has, premium flavors or unique color, and that way they can attract consumers who are willing to pay for a higher price for these unique premium quality strawberries. So high quality or premium quality strawberries can be produced in controlled environments, such as high tunnels, greenhouses, or indoor vertical farms. Because controlled environment allows precise regulations of growing environment so that they can design the environment so help the strawberries produce the best quality fruit. And in addition to producing premium quality strawberries, controlled environment also bring out the benefits such as it allows year-round productions in a lot of areas that weren't traditionally used for crop production. And if you use a hydroponic system or precise irrigations, it allows higher water use efficiency. And if the plants were grown in a vertical type of setting, which is often the case in strawberry greenhouses and vertical farms, then it can also increase land use efficiency. And that's controlled environment naturally provide protection over the crops that's grown in the environment. And so that reduce the pest pressures, and that means it reduces the amount of pesticide application as well. And in all different types of control environment systems, indoor vertical farm really allows the full control of the growing environment for the crops, and therefore might be an ideal system for strawberry if you're looking to grow high quality strawberry fruit with a very consistent environment. And because of all these benefits that the control environments bring, a lot of the strawberries in the U.S. It's more and more strawberry in the U.S. is being produced from control environment. And here's a few number I just want to share. There's from 2009 to 2019, 10 years, there's a 3 times increase in the amount of strawberry that is being produced in controlled environments. And if we specifically look at hydroponic systems, there's a 14 times increase in strawberry being produced from hydroponics. And for the sales value of strawberries being produced from controlled environment, there's a 78% increase. That means this area of industry is quickly expanding. And however, we don't have a lot of strawberry cultivars today that we can choose from specifically for controlled environment because most of the strawberry cultivars traditionally have been developed for a few productions in the US. And so there's a strong need to identify more strawberry cultivars that growers can choose from so that they can use them for controlled environment production. So to choose the strawberries for controlled environments or identify what are the candidates cultivars for indoor production, it's important to know what are the priorities are in choosing these cultivars. And the priorities for open field production is actually very different from, well, not very different, but not all the same as indoor vertical farm production. So for open field production, oftentimes people are looking for cultivar with high yield, high productivity. because they're grown outside. So it would be preferable if they have resistance to pests and disease, especially in area that have a lot of pests in the environment. And also the stability of phenotype is very important because open field environments can change, and to make sure there's consistent production of strawberry, it's important for them to have that stability. And also because most of the open field strawberries were grown in the ground. And so for harvesting, workers have to bend down quite a bit to pick the strawberries. And so if there were traits in strawberries, such as extended fruit truss to help the ease of picking, that would be really, really helpful. And also the firmness of fruit, maybe that will help with the picking as well, with the firm fruit. And because most of the outdoor production, strawberry production in the US for strawberries is in California and Florida. And so for them to reach the rest of the country, they need to be shipped over long distance. And so a long shelf life for these strawberry cultivars is very important. Versus indoor vertical farm production, which can be done pretty much in any locations that can be really close to the target consumers. And so the priorities for indoor strawberry cultivars includes high fruit quality and early production, because indoor vertical farm tend to have high operational costs as well. So if we can have early production, that will reduce the waiting time and reduce the operational costs during the vegetative growing stage. And high productivity is still very important, even though it's not the highest priority here. And so for indoor vertical farms, a lot of times space is limited. And so to be able to grow compact plants, that's important. And also, like I mentioned, a lot of resources in indoor vertical farms are provided manually and it has a high cost, such as light, electricity costs. And so to be able to grow strawberries with high resource use efficiency is also a very desirable trait that growers are looking for. And as we all know that most of the plant's phenotypes are controlled by both genotype and the environment. And that's also the case in strawberries. And so for us to really identify strawberries suitable for indoor farming, it is necessary for us to characterize the strawberry phenotype and different genotypes in a control environment that are relevant to indoor vertical farm settings. So that being said, the objective of the study is to identify strawberry cultivar with traits that are desirable for indoor farming in a fully controlled indoor environment. So to identify strawberry cultivars suitable for indoor farming, we selected 25 strawberry cultivars from USDA-ARS National Clonal Germplasm Repository. All these 25 strawberry cultivars are Fageria ananassa, which is the modern octoploid strawberries. And because we have another goal for the study, that is to use the premium strawberry cultivar selected from the study for further breeding efforts so that we can create new cultivars that are suitable for indoor farming. So because of that reason, all these strawberries were chosen from cultivars that are not protected by patent. And because of that, most of these strawberries were relatively older cultivars, and they're pretty much all short-day strawberries, except for one, which is Mala de Bois. And so in the picture on the right, you can see that there is great diversity in the strawberry cultivar we choose from in terms of plant morphology. And that's one thing that's also important to consider for indoor farming. And I'll explain why later in the presentation. So this is the fully controlled indoor environment that we use to characterize these strawberries that we selected. It's a walk-in growth chamber with a 24 square meter area. The light that we provided for these strawberries come from white LED lights with 332 micromole per square meter per second of ppfd. And because these lights were on for 13 hours short day for strawberries, that gives us a daily light integral of 15.5 mole per square meter per day. So in addition to the white LED, which provides the main light source for photosynthesis, we also have photoperiodic lighting. And the function of photoperiodic lighting is so that it allowed us to extend the day length sometimes so that without affecting the daily light integral very much. It's a weaker light intensity. And the reason for us to extend the day length sometimes into a long day condition is because even though these strawberry plants require short day to initiate flower production, it's important for them to be grown on the long day every few weeks because short day can suppress the plant growth and long day can promote the production of fruit and the growth of the plant. And so it's very important that we have alternating photo period between short day and long day for these strawberry cultivars. So in addition to light, we also have day-night temperature is 24 C during the day, 12 C during the night. The lower night temperature is meant to suppress the respiration in these plants so that they conserve that sugar and reduce the production of acid. And then we have humidity during the day is 65%. At night, it's higher at 93%, and that is intended to reduce tip burns in strawberries. In addition to all these conditions, we also supplied extra CO2 for these plants at 1,000 micromole per mole to promote photosynthesis. And these plants were grown in a cocoa-based substrates. They were irrigated through drip irrigation using J.R. Peters strawberry formula. And we use a relatively lower EC. It's only 1.0. So as I mentioned earlier, early production is very important for indoor farming because we want to reduce as much of the waiting time as possible. And so out of the 25 strawberry cultivars that we evaluated, Mala de Bois was one of the earliest to flower and produce fruit. And so it was able to produce first harvest in only 69 days after it's transplanted. And this is much shorter compared to some other cultivars, which requires more than 130 days from transplant to harvestable fruit. And this, the early production of Mala de Bois was probably related to the fact that it's the ever-bearing strawberries in the study. And that being said, it doesn't require that short day environment that we provided during production to induce and initiate flowers. The signal could already been induced during the vegetative production stage. Another reason for Mala de Bois to have the early harvest was also because that it has the shortest ripening times. So it takes only 28 days for the strawberries to go from open flowers to a harvestable fruit. And so that could also contribute to the early production time for Mala de Bois. And so in strawberry production, productivity is another trait that grower would pay attention to when they're selecting strawberry cultivars in addition to production time. So we collect weekly yield data, and based on the data we collected, we were able to calculate the average weekly yield and maximum weekly yield. And use these two parameters, we're able to classify 25 strawberry cultivars in the studies into 4 categories. The first categories have cultivars that have the highest productivity, which means they have both high average weekly yield and high maximum weekly yield. And the second and the third categories include strawberry cultivars. Both have medium productivity, except for the second category, strawberry have relatively higher average weekly yield. And the third category has strawberry with relatively higher maximum weekly yield. And then the last category in this tables are strawberry cultivars that have the lowest productivity, has both relatively low average and maximum yield compared to the other cultivars. And so because the variations in strawberry productions can be attributed to many different reasons, such as photosynthetic rate or the allocation of sugar of photosynthetic products. And so to determine if photosynthetic rate plays an important role in affecting the productions of indoor strawberries, we measured a lot of photosynthetic parameters using CIRUS-3. So the light intensity we provided for the measurement is the same as the average light at plant canopy in the growing environment, which is 332 micromole per square meter per second. And the temperature we provided also is the same as the daytime temperature, which is 24 Celsius degree. And then we also set the reference CO2 same as our supplementary CO2 level at 1,000 micromole per mole. And with our measurement, even though we did not see statistic difference in the photosynthetic rate across different cultivars, we have found that the leaf net photosynthetic rate could range from 8 to 12 micromole per square meter per second in the environment that we provided for these strawberry plants. Okay, as I mentioned, in addition to photosynthetic rate, the production of strawberries in this environment could also be affected by the sugar allocation. And so to quantify that, we characterize the plant size, the vegetative size of the strawberry cultivars by measuring 2 parameters, including plant height and the projected canopy area. And based on these 2 measurements, we were able to classify these 25 strawberry cultivars into different categories, including large plants, medium plants, small plants, and extra small plants. And this information is also very important for the design of indoor farms because the height of the plants and the size of the canopy area are very important factors to consider when we're deciding the hanging height of the light and also the planting density in the production room. And so now that we have characterized plant height and the projected canopy area, and as well as the leaf net photosynthetic rate, we ran a correlation analysis to see if there's any correlation between production and any of these characteristics that we quantified. And we did find positive correlations between plant height, plant size, including height and projected areas, and production time, including time to flower and time to harvest. And so because the correlation is positive, that means the bigger the plants, the longer it takes for them to go from transplant to harvesting. And we did not find any correlation between the photosynthetic rate between that and any of the production parameters. And that means that photosynthetic rate was not the major contributors to the difference in plant production in this study. Oh, and I forgot to mention that because we were seeing this positive correlation between the size of plants and the production time, this could be attributed to the competition relationship between plant vegetative growth and production development. So in addition to production traits, strawberry quality traits also very important in choosing the suitable cultivars for indoor farming. And this slide tells us a little bit about the fruit size. Okay, so we quantify the fruit size by calculating the average weight of individual fruit of the strawberries. And most of the cultivars that we characterized in this study had an average fruit weight around 4 to 8 grams. Is that for... Did I hear a question? Okay, just, I don't mind being interrupted for question if you do need to ask. So most of the strawberry produce a fruit size of 4 to 8 grams, except for 2 cultivars. Chandler produced an average fruit size of 11.8 grams, and Tamela produced a strawberry size of 9.4 grams. Some cultivars produce extra small fruit, such as Checkchain only has a 3.4 gram fruit size on average, and Miyazaki also only have a very small fruit average size of 3.1 gram. Now that raises a question that we're all wondering. Does bigger always means better? We'll answer that question later. So another quality traits that we quantified in the strawberries that we study is the Brix index. Brix index is related to the concentration of total soluble solids. It's also been used as a great indicator of sweetness, of determining how sweet the fruit can be. The higher the Brix index, typically the sweeter the fruit. And based on our analysis, we found that the majority of our strawberry cultivar that we grow in this environment had a Brix value higher than 7.0, which is the recommended value. 7.0 and higher as the recommended value for Brix by UC Davis Post-Harvest Technology Center. So that's great news. But we also found negative correlations between Brix and fruit size. That means that some plants that produce larger fruits may not taste as sweet as some of the smaller fruits produced by other cultivars. So bigger doesn't always mean better. However, that doesn't mean that with a higher Brix value is always going to taste sweeter because strawberry has different sugar composition in different cultivars. So a different type of sugar can really affect that sensory taste of the strawberries. So Brix doesn't really give you that idea, and it's important to follow up with a sensory analysis. In addition to Brix, Brix-TA ratio is another great indicator of sensory quality of the fruit. TA stands for titratable acidity, so it measures how acidic the fruit is. So the Brix-TA ratio can give us an idea of the sugar-acid balance. And typically, when the Brix-TA ratio is higher than 1.0, it's a good berry. And we have 4 strawberry cultivars that had Brix-to-TA ratio higher or equal to 1.0, and they are Mala de Bois, Hood, Benton, as well as Puget Beauty. In addition to all the sensory measurements that I talk about, we also noticed that in the strawberries that we analyzed in the study, they're very diverse in terms of shape and colors. And in these pictures, you can see that some strawberry has really long fruit side, and some has a relatively round shape. And also in terms of color, some berry has really dark, deep red outside color versus other cultivar has a relatively lighter color on the outside. And also the inside colors are very different. For example, this cultivar has very, very light inside color compared to some other cultivars. And so in addition to the sensory quality, we also would like to quantify these traits to help evaluate the quality of the strawberries and to provide better information for growers to choose these strawberries cultivars. So how do we quantify the color of the strawberries? Well, we quantified that using an index called NDAI, stands for Normalized Difference Anthocyanin Index. This index correlates with the surface anthocyanin content. That means the higher the NDAI, typically the redder the strawberry fruit. And based on this index, we're able to classify these 25 strawberries into strawberry with darker outside color, medium red, moderate red, and light red on the outside of the fruit. And, as fruit outside color is also an important trait a consumer would consider when they're picking the strawberry fruit in the store. But in addition to the outside of the strawberries, we also wanted to quantify the inside color of the strawberries. Now, different from the outside, the inside of the strawberry typically has a white area, and that could interfere with our perceptions in terms of color. And so we also, to quantify that, we also use a different parameter. It's called red area to total area ratio. So basically, we measure the total area of the cross section of the inside of the strawberries, and then we remove the white area to calculate just the red area. And this ratio will give us another perspective to quantify the color in the inside of the strawberry. So with the ratio, in addition to NDAI, we classify these 25 strawberry cultivars into dark red, medium red, moderate red, and light red. And all these color information will really help growers choose these strawberry cultivars really based on the market preference. So, in addition to choosing the right strawberry cultivars, it's also very important for us to optimize the production environments. The environment that we provided for these strawberries is not the best environment that we can give them. There is still room for improvement. And as I mentioned earlier in the presentation, that most of the strawberry cultivars that we analyzed in this project are short day strawberries, which means they require short day to initiate flowering and produce fruit. But at the same time, short day photoperiod can also suppress their growth and causing what's called dormancy in these plants. And dormancy can cause symptoms such as reduced vegetative growth and reduced fruit production. And one example is here. You can see in this picture, this is one of the strawberry cultivar, Nioho. And when it's grown on the short day environment, you can compare to the long day environment, you can see the height of the plants were significantly lower in the short day environment. And so using the height difference between short day and long day, we're able to determine how sensitive these cultivars are towards the dormancy-inducing short day conditions. And so the bigger the height difference, the more sensitive these cultivars are to the light, the photoperiod. And so with that information, we classify the 25 strawberry cultivars into 4 categories again, including strawberry with extra high sensitivity or high, medium, and low sensitivity. And this information will help us better understand and design experiments to optimize the light environment for indoor strawberry production. So in conclusions, we have identified a couple strawberry cultivars, Bois and Dover, from this project. They both have earlier production, higher average weekly yield, and relatively low sensitivity to dormancy-inducing short-day photoperiod. And therefore, we recommend those out of the 25 strawberries that we studied for indoor farming. In addition to these production traits, we also look at the fruit quality traits of these strawberry cultivars and provided information in different categories to help growers choose the suitable cultivars depending on what their target market is. And in addition to what we have done, we also collaborate with food scientists to conduct further chemical and sensory analysis on the strawberry flavors to better determine their quality, and that will be conducted. And in addition to food scientists, we also work with plant breeders who will use the strawberry cultivars from this study as breeding materials to create new cultivars that are desirable specifically for indoor farming. And as I mentioned, we're working on optimizing the growing environment for these strawberries because production environment, control environment can, if we are smart enough to make the environment optimized for the flavor to bring out the quality of these strawberries, then that would really enhance the quality of these cultivars. And so at the end, I wanted to thank a lot of people that provide tremendous help on this project. My supervisor, Dr. Chieri Kubota, and also my colleague, Dr. Chang-Han Kim. He was the reason that we have a phenotyping system that we use specifically for this project. And also want to thank Mark Hogel for helping me start with this project, basically designing the irrigation system, the IPM management plan, and also Puget for maintaining these strawberries at the beginning of the study, and Alex Davis, my undergraduate research assistant. She helped me a lot with maintaining the plants, harvesting, and all that great things. And I also wanted to thank Dr. Jamie Strange and Morgan Christmas for providing bees to help us pollinate these strawberry plants. And Matt and Devins are great communicators. They are leaders. Devin's the leader of this May project, and they help us make sure this project goes smoothly. And David Francis and Jonathan Fresnello-Ramirez. Those are great plant breeders here at The Ohio State University, and we collaborate with them to improve the strawberry cultivars. I can't wait to see all the new cultivars that's going to come out from this study that's going to benefit the indoor growers. And then we also have collaborators from USDA. They have helped us a great lot in choosing the correct the strawberry cultivars to use for this study, but also helping us when we run into issue with the cultivations of these cultivars. And at the end, I wanted to thank our funding source, the Foundation for Food and Agriculture Research. And Thank you for listening. I really appreciate your time, and please let me know if you have any questions.
Thank you for attending the webinar. To learn more about the Cyrus 4 portable photosynthesis system, visit ppsystems.com.